Okay, welcome everyone. In this video, we are going to be taking a look at if-then statements and their converses. So to start off, let's take a look at these three statements right here. The first one says, if I get straight A's, then my parents will buy me a new phone. The second one says, if the Cubs win the next 9 World Series, then they will have as many as the Cardinals. And the third one, a little more math related, actually should sound familiar to you. It says, if B is between A and C, then AB plus BC equals AC. And so each of those statements, you notice, they all have something in common. They all start with the word if, and then after some kind of opening phrase, there's a part that says then, right? So each one of those is actually called an if-then statement, which can also be called, sometimes you'll hear them referred to as conditional statements. An if-then statement or a conditional statement. And each one of these statements could be represented, all if-then statements can be represented by a phrase that looks like this: if P, then Q. If P, then Q, where P is called the hypothesis, which is a word you probably heard in science class before, and Q is called the conclusion. So P is the hypothesis, Q is the conclusion. P is the statement that may or may not be true. Like in science, we form a hypothesis, then we find out if our hypothesis turns out to be true or not. And Q is the conclusion that will always be true when the hypothesis turns out to be true. So let's look at a quick example where we're going to try and identify some hypotheses and conclusions in some if-then statements. All right? So to start, we have if 2x minus 1 equals 5, then x equals 3. So if we think about this statement as if P, then Q, what's the P part? What's the hypothesis? It's pretty easy to pick out. It's this idea that 2x minus 5 equals, 2x minus 1 equals 5. The conclusion, which would be the thing that would be true once the hypothesis turns out to be true, in this case, the conclusion is that x would have to equal 3. All right. In part B, it says, actually, I'll tell you what, I'm going to have you pause the video right now, and you're going to work out part B real quick. Underline the hypothesis once and the conclusion twice. Okay, let's see how you did. In part B, the hypothesis would be ray RA bisects angle SRT. The conclusion would be that the measure of angle SRA equals the measure of angle ART. So that part should be underlined twice right there. Now in part C, we got to reword this one because it's not written as an if something then something. It's not written as an if P then Q. So we might want to reword this to make it look more like an if P then Q statement. So it says the grass will be wet if it rains. As an if-then statement, that looks like if it rains, then the grass will be wet. I guess I didn't need that comma there. Then the grass will be wet. So now we can see what the hypothesis is. It's the part where it says it rains. So I'm going to come over here and I'm going to underline it rains once. The conclusion, the thing that will definitely be true if this hypothesis turns out to be true, is that the grass will be wet. So the grass will be wet. We'll get 2 underlines. In part D, we have another one where we're going to have to reword it. So I'm going to give you a chance to pause the video now and try this one on your own. Okay, let's see how we did. The original statement says every number that is divisible by 9 is divisible by 3. So if we reword that, we're going to say, well, what's the thing that might be true or might not be true? It's this idea that a number is divisible by 9. So that's my hypothesis. If a number is divisible by 9, then what do I know will be true? Then it is divisible by 3. So now hopefully I can see what's the hypothesis. It's this idea that a number is divisible by 9. So I'm going to underline that once. What will be true if that thing is true? Well, then that number will be divisible by 3. So that's just identifying a hypothesis and a conclusion. The next thing we're going to take a look at is what happens if we switch around the hypothesis and the conclusion. And if we do that, then what we do is we create the converse of a conditional. It's when we switch the hypothesis and the conclusion. As an example, I'm going to skip down here real quick to example 2a. We're going to write the converse of this first statement. So we identified the hypothesis as 2x minus 1 equals 5, and the conclusion is x equals 3. We're going to switch those around. In other words, if our original statement was if p then q, then the converse turns into if q then p, right? So let's rewrite part A as its converse. We would say if x equals 3, so we'll put the conclusion of the original statement where the hypothesis goes, then 2x minus 1 equals 5. That was the hypothesis in the original statement, so in the converse it becomes the conclusion, right? Now, sometimes the converse of a true statement will be true, but sometimes that converse of a true statement will actually end up being false. Let's take a look at part A and see, does this converse end up being true or does it end up being false? Well, if x equals 3, is it true that 2 times x minus 1 will give me 5? Well, let's think about this. Does 2 times 3 minus 1, does that equal 5? 2 times 3 is 6. 6 minus 1, yeah, it's 5, right? So that means that this is a true statement. This converse is true, and the original statement was true as well. In part B, let's write the converse. We're going to take the conclusion if the measure of angle SRA equals the measure of angle ART. Then, now we'll take the hypothesis of the original statement. Ray RA bisects angle SRT. Now let's decide, is that a true statement or not? Well, first I got angle SRA. So let me create a quick sketch of angle SRA. That's going to be equal to the measure of angle ART. So A down to R, and then over here to T. So I have this angle and this angle congruent to each other. Is that true that ray RA has bisected angle SRT? Well, yeah, it is. So that one is also true. Now I want to let you guys try C and D on your own, and then we'll see how you did. Okay, in part C, our original statement said the grass will be wet if it rains. So we said the hypothesis was it rains, conclusion, grass will be wet. Let's switch that around. If the grass is wet, then, now we put the original hypothesis, which was it rains, then I'll say it has rained. Now, is that true or false? If the grass is wet, does that guarantee that that it has rained outside? Well, no, the grass could be wet for a number of reasons, right? So we will say that that's false. In part D, every number that is divisible by 9 is divisible by 3. We wrote that to say if a number is divisible by 9, then it is divisible by 3. So we're going to take this second part. If a number is divisible by 3, and now we'll put that in the hypothesis, and we'll take the hypothesis of the original statement and put it where the conclusion goes. Then it is divisible by 9. So now let's think, is that true or false? If I can divide a number by 3, does that guarantee that I can divide it by 9? Well, let's think. What's the first number that you can divide by 3? It would be 3 itself, right? 3 is divisible by 3. Is 3 also divisible by 9? In other words, if I do 3 divided by 9, do I get a whole number answer? Well, no. I get 0.33333, right? 0.3 repeating. So I'd have to say that this statement is false. The original statement was true. If I can divide a number by 9, I will be able to divide it by 3. But the converse doesn't end up being true. All right? So we need to realize that a conditional statement is going to be considered false if it is not always true. If the statement is not always true, we have to say that it's false. This means that if one example can be found that disproves a statement that shows that it won't always be true, then that statement is now going to be false because we found an example where it's not always true. Those examples that we can find, those are called counterexamples. So such an example is called a counterexample. So let's do example 3 real quick. Let's provide a counterexample. We've talked about a couple, right? We had a couple false statements here, and we realized that C was false because maybe the reason the grass is wet is because the sprinklers were on, right? So I would say grass could be wet because of sprinklers. Right? That's a counterexample. It shows that it's not always because it had rained that the grass is wet. For D, we also found an example right here, right? 3 divided by 9 equals 0.3 repeating. So 3, in other words, 3 is not divisible by 9, but it is divisible by 3. So that's a counterexample because we showed that just because a number is divisible by 3, it won't always be divisible by 9. The last concept that we need to talk about in this video, in this note sheet, is something called a biconditional. Right? If a conditional and its converse are both true, like in examples A and B up above, then they can be combined into a single statement that has a name. It's called a biconditional. Biconditional. These kinds of statements always utilize the words if and only if. So let's take a look at example 4, and let's write these two statements. They are both true. These are two if-then statements that are true. Actually, one is the converse of the other. If the quantity x minus 1 times the quantity x plus 8 equals 0, then x equals 1 or x equals negative 8. And then the converse of that takes the original conclusion, puts it at the beginning. If x equals 1 or x equals negative 8, then, now I have the hypothesis of the original statement, then the quantity x minus 1 times the quantity x plus 8 equals 0. So I have a true statement here, and its converse is also true. So I can write this as an if and only if statement. I can say if and only if, and I'm going to write it as if and only if x equals 1 or x equals negative 8, then the quantity x minus 1 times the quantity x plus 8 equals 0. You could have written it the other way. You could have said if and only if the quantity x minus 1 times the quantity x plus 8 equals 0, then x equals 1 or x equals negative 8. Either one would work, but that's an example of a biconditional. I can write that because both the original statement and its converse were true. Last, we're going to take a biconditional and write it as two separate statements. Kind of do the reverse of what we just did in example 4, right? We have a statement that says the measures of two angles are equal if and only if the angles are congruent. So I'm going to take that and I'm going to break it into two statements. First, I'm going to say if the measures of two angles are equal, then the angles are congruent, right? That's one statement that's true. It's an if-then statement that's true. If the measures of two angles are equal, I should have said, let me go back. I needed to say not congruent. I needed to say equal there. If the measures of two angles are equal, then the angles are congruent. Now I take the reverse, the converse I should say, the converse of this statement would say, if two angles are congruent, then, and I just put the original hypothesis at the end, then their measures are equal. And so I took that biconditional and I separated into two if-then statements, where one of them is the converse of the other. All right, so that's about all we have for this video. Thanks for joining me, and good luck on any homework that you have to complete.